Alright, so today we are learning about transforming exponential and logarithmic, I can never say that word, log functions. How can I transform these functions?
Who uses this? Well, psychologists can use transformations of exponential functions to describe knowledge retention rates over time.
So how much you remember.
Exactly.
Sweet.
So this is basically says that you can perform the same transformations on exponential functions that you performed on polynomials, quadratics, and linear functions.
Yeah, so if it's on the outside, we move
exactly,
up or down, inside, left or
right.
Okay.
So we're very familiar with this.
Okay.
One thing we're not as familiar with is an asymptote is a line that a graphed function approaches as the value of x gets very large or very small. Exponential functions only have horizontal asymptotes, which means y equals, that's a horizontal line, and log functions only have vertical asymptotes. That is very, very important to remember.
Okay.
So next page. And I'm struggling to, oh, I'm there. Oh,
yeah.
It went, okay. So example number 1, there's an exponential function. So we're just going to kind of go through it with you. That's the best thing.
Yeah.
So the parent function in this case is f of x. So let's write next to where it says parent function, Miss Boyd, let's write f of x is equal to 2 to the x. That's it. Okay. Because remember that the 2 to the x minus 2, a transformation is being done.
Yeah, we're going minus 2.
Which means you're going to the right 2.
So,
because x minus, yep, so it's to the right 2. Exactly. The asymptote, as you can tell by the graph, is at y equals 0. So you can write that where it says asymptote, y equals 0. Because you can tell they're not crossing that line.
Gotcha.
So the transformation in this case is right 2.
We already wrote that. Yeah.
So you can write that right there.
2.
Now we're going to graph the parent function and the transform function, which we did for you. Notice the blue is the original, and it moves to the right 2. That's the red. That's the new function. The y-intercept we also need to find for these problems.
Okay.
Well, how you find a y-intercept, you all know how to do this.
Plug in 0.
You have to set x equal to 0.
Right.
So maybe let's write that. Set x equal to 0 and solve for y. So let's do that. Let's plug in back into the original function. X, yep, that's perfect.
2 to the 0.
Minus 2.
Minus 2.
Which is 2 to the negative 2. Well, we never leave a negative exponent, Miss Boyd, right? So that's the same thing as 1 over 2 squared, which is 1/4. Or you want to write also, they could either write 0.25. We'll let you know if we want fractions or decimals.
Okay.
Okay, let's go to the next one. Well, let's look at this one now. The parent function on this one is going to be f of x equals just 5 to the x, not 1/3. Remember, that's a transformation going on up there. So the parent function is just 5 to the x power.
Gotcha.
Now let's skip down to transformation.
Okay.
Notice we have a number in front. That means we're either compressing or stretching. Because it is less than 1, it is a compress by 1/3. And if you look at the graph, you can see that the original function is in blue, the new function is in red, and remember it's like a garbage compactor, like compacting your garbage down. You're pushing the graph down towards the x-axis.
Gotcha.
All right, the asymptote, I'm just kind of skipping around, would be y equals 0 again, because they're not crossing that line. You could have y equals 1, you could have y equals -1. It depends on the problem.
Okay.
Now let's do the y-intercept. So let's just, let's go back to the original function, and you're going to set x equal to 0. Well, anything to the 0 power is 1, so the answer is just going to be 1/3. Right? Because 5 to the first is 1, is 1/3.
So y equals 1/3.
That's it. That's what you're doing on these problems.
That's easy enough.
Pretty straightforward. So let's see what's next. Let's go to the next page. What do you think, Miss Boyd?
We could save, how many do we have?
Should we see how many we have here?
Yeah.
Oh, yeah, because maybe we save this one
Yeah,
for
let's
class.
save this one and do that
And
one,
let's
'cause
do the
it's-
natural,
there's
let's do the
lots of
natural
things.
log one here.
Okay.
So now we have a natural log. So it's a little different. Remember, the asymptote is going to be a vertical asymptote when it's a natural or log. So the parent function here is going to be just natural log of x. That's it.
ln.
Yep,
of
ln
x.
and then x.
Perfect.
That's it.
That's what I thought.
The asymptote, let's jump around. Let's jump to
Okay.
the asymptote. So notice the asymptote here is going to be a vertical line, and the vertical line is going to be at x equals
equals 0.
-1, actually.
-1.
See, you look right there.
yeah.
See how it's going up,
I see
but
it.
it's
Never
not crossing it.
Yep.
Yep, that's -1.
Okay.
Now the transformation here is going to be a lot is going on.
Mhm.
The negative in front
Flips it.
reflect over the x-axis. Remember, that
Yeah.
means your y value changes.
We're adding on the inside.
Which means you're going to the
left.
left one. And
then
the
we go
down 2. Oh my goodness, a lot is going on.
So you got to remember all this stuff from before.
Exactly. Now the y-intercept, let's look at the y-intercept.
Sure.
So to find the y-intercept, let's set x equal to 0.
All right.
And you
So
might be
we
hearing
have-
the morning announcements as we're going through
That's
this
okay.
video,
We'll
because we're
finish.
running short on time. So 0
0
plus 1.
minus 2.
Well, the natural log of 1, because 0 plus
Right.
1 is 1, the natural log of 1 is 0.
0.
Yeah.
Okay.
So that whole thing is going to be
So-
0.
This is all 0.
And then
minus 2.
is a -2.
Just leaves us with y equals -2.
Exactly. And
Okay.
that's it.
Nice.
So if we go down here, what I'm thinking we should do is I think example 5 is a good one to do in
Yeah,
class.
I think so too.
So we're going to skip that. And now you're on to your video questions.
Great.
So you're going to write the transform function.
Yeah.
So look at all these. And then what is your
Saying
favorite?
We want to go 4 units to the right.
Right.
So how would we change it?
And then what is your favorite
And
color?
silver.
All right. Have a wonderful rest of your day. See you
Bye.
tomorrow.